Okay, this is lesson 2.4. Before we get into that, let's start looking at some of the things that we've covered in the first few lessons of this unit. So first of all, we want to make sure that you can remember things like Hoy and Fuchs. So Hoy relates to horizontal lines having zero slope and their equation starting with y equals. So you can see a horizontal line here, goes through 3 on the y-axis, and that has a slope of 0. The Fuchs is vertical lines, have an undefined slope, and their equations start x equals a number. Make sure we know the different types of slope, positive and negative, but also what we just talked about, 0 because it's horizontal from Hoy, and undefined from Fuchs because it's a vertical line as well. So as we're doing slope, we still want to think about those two things. A little guided review here. So we're looking for lines that are in this form y equals mx plus b. This is called slope-intercept form. M is the slope, that's the number in front of the x, and b is the number that does not have an x with it, and that's the y-intercept. So if I'm doing 1/3 x minus 4, I really want to look for the number without the x first. So in this case, it's -4, and that's why my graph starts at -4 on the y-axis. Ones equations that start with x equals, we tend to want to look at the x-axis for those ones, but certainly y equals, we're looking for that number here. The 1/3 x is the slope, and the slope tells you rise over run. So it means you go up 1 and you go right 3. So if I'm plotting this, I would go up 1 and then right 3. If I can do it again, I should. Up 1, right 3. And you should notice that that is linear, and you can actually draw it up with a graph. When we do this on IXL, once you plot 2 points, it does actually draw the line for you, but I can't do that on Desmos, unfortunately. -4x plus 5, it does start with y equals. So the number without the x is the y-intercept, which is why I'm starting at 5. And then we can see the slope to -4, but it's not a fraction this time. So it's not as easy to do rise over run with. So it's important when that does happen that we remember to put it over 1. Some people certainly tried doing this, going down 4, 1, 2, 3, 4, and putting the dot here. But notice if you put the dot there, that's a vertical line, and that would be undefined slope. So we do need to remember to go across one space as well, to the right. If we can do it again, we should. 1, 2, 3, 4, and 1. And I'm thinking I'm starting to run out of space at this point. So let me just go ahead and connect those 2 points together. So that was one of the key skills that we looked at, certainly in lesson 2.2. Y equals 3. Notice it's just a single number this time. So we know it's either horizontal or vertical. As Hoy has a y in it, we know this is a horizontal line. So starting from 3 on the y-axis, we just want to draw a horizontal line going through that point. And for x equals -2, single letter again. So go to -2 on the x-axis this time, because it's x. And because of Fuchs, with it having the letter x in, I'm going to draw a vertical line this time, going through that point there. So 4 different types of question. Certainly look out to see which one it is. But ones with one variable, you want to be using Hoy and Fuchs. And ones with 2 variables that start with y equals, you want to be using that slope-intercept form. And this was the answers for people who didn't just see the video I just presented. And then there were some questions for people to answer using warm-up. And you can see these by going to the Desmos lesson anyway. And you could try those questions for sure. So this lesson here, oh, that says 2.4. It's supposed to say 2. Oh, no, that's right. That is 2.4. I think the previous slide was the wrong one. Yeah, 2.3. We had a change in lessons. We needed to bring in something a little earlier, so we're trying to change this a little bit. So today, we're going to look at finding the line of best fit, interpret what the slope means, and also identify the domain range of the data. And we got a few questions to do that. Before we start lesson 2.3, the next 4 slides covers what you're supposed to know about x, y, and x-intercepts and y-intercepts for middle school, and also now in lesson 2.3 as well. So the x-axis certainly goes across, the y-axis certainly is the one that goes up and down. So when we're looking at x-intercepts, we're looking at this point here, where does it cross the x-axis, and the y-intercept is where does it cross the y-axis. So nothing too detailed, but also notice all these x-intercepts have the y value as 0. So when we're doing our x-intercepts, it should always be something 0. And similarly, when we're doing the y-intercepts, notice they all start with a 0. So in other words, the x value is 0, and then the y value is something else. Let's start off with those lines of best fit. So talking about domain and range, from middle school, what they're expecting you to know is that domain is the x values, they'll be the ones on the left, and the range is the y values. 1 on array. So for this, you can clearly see that the domain would be 1, 2, 3, 4, 5, and the range would be 2, 5, 8, 11, 14. You should always have the data going from smallest to biggest, and there should be no repeats. So if the data was 1, 1, 2, 5, you wouldn't put 1, 1, 2, 5. You just put 1, 2, 5. You don't need to repeat the second one. This one, all the values are different, so it's not such a big thing. All right, let's take a little look at this pattern, see what's going on here. I can see a square with triangles around the outside, and then 2 squares together, and then triangles at every point around the outside, and so on. So if we look at this pattern here, I've actually added pictures here so we can see it a little bit easier. It says y is the number of triangles. So on this first picture, 1, 2, 3, 4. On the second picture, 1, 2, 3, 4, 5, 6. And if I was to draw the third picture, and I'll let you do that yourself on paper, you should find out that it's 8. Now, what we can see right now is this certainly looks linear. Now, we have a line here that's been drawn, which is clearly linear, but that's not the line that represents this point. So what we're trying to do in this lesson here is, how do we create that line of best fit? Rather than just drawing it by hand, we're going to use these things called sliders. So we have our equation here, y equals mx plus b. So m is the slope here. So if I was to move this slider around a little bit, you can see that the steepness of my line starts to change. And I can make it go negative, I can make it go 0, and I'm just going to leave it right there for a second. I can also use the y-intercept as well. So notice as this number gets bigger, the y-intercept moves up and down. And one of the things I really want you to do in this unit is notice the effect that happens on slope. As the number gets bigger, it gets steeper. And for the y-intercept, as you change that number, it moves the graph up and down on the picture. So as I'm trying to match this up, it looked like I actually had the slope yeah, the slope looks good. It's just a little too high now. It's above all those points. So I should be able to move this around, and I think, there we go. Perfect. So I found the slope was 2. I found the y-intercept was also 2, actually. So the equation for this line would be y equals 2x plus 2. So we are actually looking now at equations of lines, not just saying it's linear. We want to find out what that equation is, but we also want to think about how do we get that line to where we want it to be in terms of manipulating the slope and manipulating the y-intercept. Think what figure 0 would look like, and why is b equal to 2 in this question. All right, so let's see what we've actually got here. So what I'm noticing then is every single picture has 2 triangles on the side, and what's changing is the number of triangles on the top. So in figure 1, I have one set of triangles top and bottom. On figure 2, I have 2 sets of triangles on top and bottom. If I was to carry on for figure 3, I'd have 3 sets of triangles on top and bottom. So if I was to work backwards then for this, for figure 0, I would have 0 triangles on top and bottom. All I would have left is literally these 2 triangles here. That's why the y-intercept for this question would be 2. So that can be a little difficult to think about, but you kind of got to work backwards on pictures, see what the pattern is, and then figure out what the previous picture would be as well. Look at the change in x and the change in y, work out the change in x and the change in y, i.e. the slope. So yeah, as we're looking at this picture here, we can see that it's going up 2, it's going across 1, going up 2, going across 1. So in each case, it's 2 divided by 1, which is 2, and that's actually what the slope is for this question, as we already saw. So if you can see points, you can actually count slope straight away. So rather than just trying to manipulate the slider, you can physically work out what it is and actually change the slider to that number if necessary. Now, also with this, they want us to start thinking about not just using the generic rule, but thinking about what these things actually represent. So if we go back to the picture here, you can see here, this was the figure, this was the number of triangles. So in this case, x is the figure and y is the number of triangles. So as I'm writing my rule here, instead of saying y equals 2x plus 2, I know y is the number of triangles, so I can say the number of triangles equals 2 times the number of the figure. That's because they're next to each other, so we know it's multiply, and then add 2. So they want us to start putting this in context. So in terms of a word problem, thinking about what each of the different variables represents and then using that. If we're doing domain and range, remember domain is just the x values, and the range would be these ones here. Now, although we only looked at 5 figures, we could continue, 3 figures, we could continue this pattern forever and ever and ever. So we might actually want to say for this one, the domain for this one is all positive whole numbers. We're not going backwards, but starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, might be able to shorten that. And similarly for this one, 4, 6, 8, we can see it's going up by 2. We might recognize those as even numbers. So you might actually want to say the domain is all even numbers 4 and above. Now, it does depend on how the question's phrased. If it's talking about what is the domain for just say the first 5 pictures, then we might just want to say 1, 2, 3, 4, 5. But if we know that this pattern continues forever, we might want to include that within our answer as well. Now, not every scalar graph will be a perfect straight line, but we are looking to see if there's a pattern there. So as I'm looking at these values here, particularly the ones at the top here, you can see that we're kind of going upwards here and same here. So the line of best fit doesn't look really too close, like it's not touching really, well, it's touching 1 point. There's a lot of them that aren't going there, but we can certainly see that that's the overall pattern. And we can also try, if we can, try and get as many points above the line as below the line, if possible. I think for this one, it's slightly closer to this one, just because there's more points here. And if there's more points here, we probably want to move the line a little closer to those ones as well. These are probably possibly outliers, as in they're not as typical as these values here. Okay. This question talks about x, which it says is the height in inches. We can see that down here. And y1 is the weight in pounds. Now, notice this doesn't start from 0 because nobody's obviously 0 inches tall. And similarly for the weight, this actually does go down to 0, but nobody's going to weigh 0 pounds either for obvious reasons. Now, as I'm looking at this pattern, with my mind, I can see that this certainly looks like it's going upwards. And if I kind of split this in the middle, I would want to go somewhere around here. Now, the line I'm sketching here with this arrow is steeper than this line that I've got drawn here. So as I'm moving my slider, right now it's at 1.4. I know that that's not big enough, so I want to make it bigger. Now, also, as I'm drawing this, I'm trying to think about where that y-intercept would be. Now, that's actually a little tricky for this one because I can't actually see the end of this graph. It's certainly below 0, I can tell that. So let me move that around a little bit. I don't think I have the steepness of the line good enough yet. Let me move that back around. That's not too bad. Still think I want it a little bit steeper. So let me go there and let me move it down a little bit. Oh, I think that one I'm much happier with. I think that's good. Now, it is a little bit guessing for sure. There is a way to find the definite line of best fit, and that will actually come in a later unit. That one I like even more. I basically got half the values above, half the values below. I think that's a pretty good one. So M is 4.6 and B is negative 177. In my case, you might find it slightly different to that one. And in fact, on this one, I end up with something slightly different. I had 4 and I had negative 140. So it will change from time to time. So I found the rule was 4x minus 140 on the second one I just showed you. And remember what the things actually represented. So 8x was the height in inches and y was the weight in pounds. So instead of saying 4x minus 140, I could say the weight in pounds is equal to 4 times the height in inches minus 140. And the reason we might want to do that is we might want to make a prediction. So if we know that somebody is, say, 6 feet, which is 72 inches, we can actually substitute that number into this formula and actually come up with a reasonable prediction of what they might actually weigh. Now, as we're talking about domain range, domain is all the x values, range is all the y values. Now, we have a lot of values here. Now, we're not going to list every single one because we can't tell exactly, and that would be too difficult. But as I'm looking here, it certainly looks like there's no values for the x that are below 50. And I can see this is 70. Oh, it's a bit more than 70. So 72, 73, not exactly sure, but something around the 50 to 72 seems to be a reasonable answer for this question. And similarly for the range, the smallest value here I can see is 50. So the lowest person was 50 pounds. There's 150. And I'm not sure on the scale. I think it's possibly 5s here. Oh, sorry, this is 10s. So 160, 170, 170 something. I went 175. I'm not 100% sure, but that's why they'll give you multiple choice answers because we can't tell definitively, but we can get a rough approximation of what the answer should be. In the next example, we'll try to find the line of best fit. We'll also look at how you change the sliders when they aren't what we want them to be. Okay, so on the last couple of questions, we've been just fine. This one here, as I can see, first of all, the slope is way too steep. I need something like this. So actually, I want to make this smaller then. So, Now, as soon as I moved it smaller, do you see how it disappears off the page here? So one of the problems we're going to have here is because this y-intercept is 0 right now. So as I draw my line through this point, I can see that the y-intercept is going to be something like 56. But you can see I can only get up to 10 here. So if I want to change that, I can click on it and I can pick what's the smallest value I want. Well, I said it was 56. I'm going to go from 0 to 100, and that should make it a lot easier. You can choose how much it goes up by. I'm just going to go up by ones, and I said I think it's about 56. So let me go to 56. And that actually seems like that's way too high. Oh, what I failed to notice is this says 9, so this would be 8, and so on. So yeah, I went way off the graph. Oh, here we go. Here's my line. Let me change that steepness because I could see that that was too much. And let me see if I can move this around a little bit. There we go. So now we're starting to get to something a little bit closer to what I was looking for. And you just move that line up. Oh, there we go. That's not too bad. Something like that, perhaps. I only have 3 below, and it looks like I have a few more. So I might want to move it up just a little bit. Perhaps I got a few more between. Now, you can actually just change it directly here. If 51 was too little and 52 is too much, perhaps I want to go 51.5. There you go. You can just type over the top as well. So if the sliders don't work, you do have the ability to change them as we're going along. Analyzing other data using CodeApp. So you will need to log into this activity so you can actually click on this link, but it will actually tell you how you can start using different data, already created data samples. Now, if you don't know how to do something, it will say show me. So it says drag this data file into the code app. So I'm just dragging, and if you do it right, it'll give you a little check. Now I can see I've got some animals here, and I can see I've got things like how long do they live, what's their height, what's their weight, how long do they sleep for, what's their speed, etc., etc. Make a graph. Well, I can see at the top it's graph, and I've actually done this tutorial already, so I'm just going to go ahead and click on it. And you can see it'll actually give me a scatter plot. So move the table or graph. Well, I can just drag it like this. There we go. That's done. Drag an attribute to the graph's axis. All right. Well, I'm going to look at, is there a connection between the height of an animal and the weight of an animal, or its mass in this case? Oof, well, we've certainly got some strange numbers here, but possibly if we just looked at these ones here, there seems to be some sort of trend. Certainly as we're going further along, these values are going up, so there might be a connection there. And if you want the variables the other way around, like if I had messed it up, you can switch it like that as well. Now, there's a few other things that you can do on here as well, and I think we see those in the next video. So let me see if I can get back to where I was. And this is where that box gets in the way. There we go. So let me go to the next slide and do tutorial video for 2. You should follow along and do this. I've done this 3-4 times now, so this is just a little bit easier for me. Yes, let's follow this one. All right, make a scatter plot of height versus age. Well, I certainly want to do a graph. And what does it say? I want to do height versus age. So let me put on height. And let me put on age. There we go. And we can see, ooh, that kind of gets very steep here. Looks like there's a little bit of correlation here, but it looks like it's more curving than anything. Anyway, drag a selection rectangle around a subset of points. Let me make this just a little bit bigger so we can see. There we go. So you can change the size of the picture as well. So if there's some that are particularly interesting, like these ones here seem to be more like linear correlation, you can actually just drag and focus on certain ones. Hide the unselected cases. Now, I don't remember what this is. I could click on it. Oh, there we go. Hide unselected. So I'll do that, and then we can just focus. So you can actually choose to look at certain data and not other data. So it might be perhaps I'm only interested in animals that are under 160 centimeters, and I can just focus on those very quickly. Deselect all cases, including the ones in the table. So you just literally click back on the grid. There you go. They're all been deselected. Rescale the graph. I think that's the ruler. Oh, perhaps that's not the ruler. All right, I don't remember. So let me click show me. I thought I remembered how to do this. What's it saying up there? Oh, I can't actually see what they did there. Is it literally just that? No, that wasn't it. Look what we got here. Nope. It doesn't help when my picture's in the way, unfortunately, either. And that's even less helpful because now that's in the way again. Let's have a look. What does that one do? And I found just by kind of playing with this as well, it's kind of, yeah, unfortunately that picture is so small there. I can't actually see what they did. Let me try one more time. Rescale the picture. Oh, we click on the top. Okay, all right, so let's do that then. So click on that. Ah, okay. So it's kind of squashed into the bottom. So by clicking on this icon here, you can see it spread it out. And this certainly looks a lot more like positive linear correlation right now for sure. Adds sex as a legend to the scatter plot. Now, right here, I don't know anything about these animals. I don't know if they're male. I don't know if they're female. So you can actually add that to part of the picture. So I'm dropping this within the graph. And then now notice you can see. So these are female animals. These are male animals. Now, I don't have many male animals on this one. So it might just be a case of perhaps I just want to deselect those ones. Looks like, unfortunately, I got a little bit too much on this one, but hey, I'm going to hide that one and let me get rid of that one as well. So I'm just combining a few couple of things that we saw together here. But that's just a little introduction today. You are going to use this later in the unit and perhaps later in the course as well. So for today, we just wanted you to get a little introduction to how you actually use this. The tallest buildings in the world. So having had a little play, having had a chance to find, this is kind of like that mini investigation we did at the end of Unit 1, except for today, you got some data given to you straight away. So you don't have to collect anything. You can look at different buildings here. Let me move this out of the way a little bit. There we go. I might want to move that out of the way and this out of the way. There is some instructions here that you can do. And there are some other things we can look at as well. There we go. See, we can make that a little bit bigger. What other things do we have? Hey, perhaps there might be a connection between the height of a building and the year it was built. I think in general, buildings are getting taller as we get along, as we go further into history. That might be something I want to investigate, and then I can play around just looking at those two things. So I talked about height there. No, actually, height's already plotted. And I wondered about the year built. So let me put on the year built. Oh, that didn't work. There we go. Oh, you got to make sure it's changed color. And difficult to see, so I'm going to click on that icon again and make it a little bit bigger as well. There we go. That's better. And actually, I'm not sure. Doesn't seem to be as much. That's why we do these things. Sometimes we don't know the answers to questions. This is a good way of actually finding out. I can certainly see some of the later buildings here do tend to be, some of the ones in the 1930s definitely seem to be smaller, but I can see that there are some much bigger buildings here. One thing I can tell for sure is there's a lot more buildings that are 300 feet and above in 2010 onwards than there was in 1930, which is not surprising using the technology. All right, that's the end of this lesson. So we're just kind of introducing a few things, getting you used to using technology, answering questions based on it. And that's really to set up for the following lesson that's coming in 2.5.